with industrial members supporting the project. Natron is already used among some major worldwide studios currently, and we heavily focus on experimental users. Over the last year, we have released version 1 in December, I think, and we have presented it at the SIGGRAPH 2014 in Europe, and we got a lot of feedback and a lot of requests, and the main request was they wanted to have some sort of integration of 3D workspace and 3D tools. And well, the next thing is mostly 2D interaction, so it was really vague and people didn't really tell what they wanted. So we got a lot of interaction and discussion with artists, and we figured out what people want actually, some sort of interaction with 3D software and as they render interactively in 2D. So I will describe later on what we did with Libre and how we try to create this sort of interaction. And lastly, Natron received the award for Best Innovation in January in Paris Images Digital Science. A quick word on the market and how the software is out there. So the main contender to Natron is Libre, which company is going to be sold in July this year. Rumor says this is going to be bought by Adobe, which ironically also has its own custom software for After Effects, which has a user base. And then it's followed by Fusion 7, owned by Blackmagic Design. And recently, the visual effects house called Buff said they wanted to sell their own software for Libre. Internally, Natron relies on OpenFX, which is an open standard for visual effects plugins. This is used in maybe 10 to 11 applications currently. Most of them are commercial, except 2 applications, one for Bootleg effects developed by Natron and our application. Natron aims to become a stable computing software to which companies and independent artists can build solid base of software. It is known fact that nowadays producing a movie involves not one but dozens of VFX houses, each of which have different tools and scripts. It becomes very tedious to work with each other, and it is a real need to have a common base of software to exchange and work with. Currently, it's a need also to have some sort of software which is stable enough to avoid corporate relying and stuff. So yeah, Natron is not out in a few schools France. So you may have heard of the feedback post saying that it was used as a replacement to Photoshop in University Paris 8 in France. But they also did the same with Blender and Natron. So I'm going to go into details into what we develop and into the integration towards other software. So the first thing we implemented is Python 3 integration. So we chose Python because this is a widely used scripting language, especially in graphic software. So the first thing we can do with Python is expressions. So this is used mainly in motion design. So I'll show you a quick example of how we use expression in Natron. So this is not no, I don't see it. I should be able to. So yeah, I've got a simple graph. This is a small dot. And what I did is I created a quick animation with keyframes where the dot just bounces around like a black diagram. And what we want to do with this expression is, for example, we would like to create a loop effect. So the ball will bounce the whole shot for maybe 20 seconds. And if I take a look at what the animation curve loop for this bouncing effect is in fact composed of 5 or 6 different. And what you want to do here is you want to replicate this animation curve over the whole sequence. So we're just going to apply predefined expression. You can see here. So we say we want to loop, and you can choose a frame on which we want to do. So let's say 48 frames, which is exactly the length of the animation at here. And this will automatically is Python expression, which is right here or here. You can try to understand it now. Not going into details. So this will loop, in fact, the whole animation. And now we can have our ball bouncing for the whole duration of the shot. So now let's get back to the presentation. And also integration of expression is if you want, for example, to control the output pixels. Like you want to say, okay, but the red value is a blending of two images and stuff. You really, as a user, want to have control to what effect is applied. So we talk about integrating Python to do this, but in fact, Python is not really multi-threaded. Python allows multi-thread for Python code, but really, in general, Python is really single-threaded, and Natron is heavily multi-threaded. The whole architecture is designed around using multiple cores at once. So having a synchronization node in the graph is really not efficient, and you get terrible performances. So we chose instead to turn into the STX language, which is developed by the Walt Disney Animation Studio, and which basically allows basic mathematical operations such as multiplication, cosines, and stuff. And it also allows input pixel fetching. So here, in this small example, what I do is I just basically blend the over operator, the left for all image, and the wave fetching pass on the right. And if you're wondering what is a CS in the formula, CS is source code, and it yields the results below. So an application of this SCX node can be used for interactive lighting. So generally, lighting is something done in 3D software such as Wonderman and Blender, and generally it involves doing all ray tracing and stuff. And with very complex shots, it can take a lot of time. In 2005, the Pixel Animation Studios have developed technology called MPix, and they claim that basically they would have render times of about 10th of a second for a shot versus 2,000 seconds for a render of the 3D render. So in fact, what they do is they export all the normal passes and positions of light and stuff from the 3D software, and they use it in a compositing package to simulate the rendering without using ray tracing. So I'm going to show you a quick example of how we can do this in Natron using the SCX. So okay. So here I've rendered a monkey on Blender. So what we are interested in here is I've rendered the normal parts, which I can see up here, and so here is a SCX node right here, and you can just write a little script inside of it. So this is a basic formula of the form model, which is a Gaussian reflectance formula. So I've added a few controls in these scripts, which can be found here. And basically, it controls the specular exponents. So you can increase the specular rotation, decrease it. Or I've got another control here, which is the light position. So since Natron is not a real 3D workspace right now, I separated the light position into a 2D widget here. And control the XY coordinate and a depth slider, or I can just adjust the light. So you can see that the render time are extremely fast. Even though this is a single model, it would also be fast in Blender, but here we could have millions of models at the same speed because we are not using any real information, but just simulating the lighting. So this is not as static as it would be as a result of the ray tracing operation. It's much faster and interactive. So in this way, we provide a way for artists to have a quick look of quick setup of the scene, and then you can send it back to the 3D renderer and add the final shot render. I also added basic controls where you can adjust the diffuse color of the model and stuff. So yeah, this is one of the first interactions between Blender and Natron where you can actually set up quickly all your lighting in Natron and then export it back to Blender. Another application can be for text mapping. Generally, it's just you put an image and you map it into a 3D model. When you have thousands of polygons, it can take a long time. And with the same principles in 3D screen space, it's really easy to just map texture onto a model with just using the UV path. So more generally we have worked on to replicating the render engine of Blender, which is called Cycles. So on the Blender wiki, here they describe how the blending of the different classes obtains the final output code, and we've tried to replicate this into the composting software into this free space while instantaneous renders rendered. And so we could interactively set up all the compositing tree. So I'm going to show you an example on this thing that I prepared. Okay. So this is a basic spaceship that is moving in space. The spaceship was done in Blender, and the background is just a synthetic wave. And what's interesting here is this node called Blender passes, which are made. So if I double click on it, it opens up another node graph, which you can see here. So what we can see here is that the spaceship has multiple passes, and we can separate all those passes. Here we have the diffuse color, diffuse direct, glossy color, and same for the emission pass on the right. So what we will do is we will try to replicate what is done in this diagram, so we have the same output of what cycles we do. So if we just follow the formula and merge with plus the direct diffuse and direct diffuse, multiply it with the diffuse color, and do the same for all the passes. And in the end, I just added a grain node, which so the grain node can have a multiply parameter into which you can control the strength of the pass. So on the blended passes node, I've added 3 sliders there, which control the strength of each pass. So let's say I got a reflection pass here. I can just control the strength of the reflection. So now you see the spaceship, the reflection is much lower. And I can just interactively change the reflection. Same for the emission. So the emission passes in fact to the reactors, but we don't see it very much. So what we did here is we just try to replicate what is done in cycles, but in cycles such a one where we take like 30 minutes, and we do it very much in a second. So what another technology we have developed is, what if we were to use this blended passes now and we want to use it in another project? So we have created an export mode called Libre. So basically you can export this settlement graph you see into Python script, and then we can reuse another existing tree. So in the future, we would like to also implement a 3D workspace, so we can just in Natron directly control the 3D position with the light, and then send it back with a code back with an IP circuit between Blender and Natron. We also like to have a camera position from Blender, and so I like 3D cards into which we could project textures, and this would enhance all the workflow of working with Blender. Currently, we are also working on the Unique integration. Unique is a scripting language developed by the Libre, French laboratory, and with this script language, you can develop hundreds of effects. And this is currently using here, and we are in the process of porting it to use it in Natron. And more generally, we want to bolster free open source software integration. I want to propose an export mode of the final render of Natron to shortcut and open shot. And since there is a huge user base of After Effects, so we like to guide people into using node-based softwares by proposing an import of After Effects projects so that users start to understand how it works in a node-based environment instead of pages. Anyway, this is a quite short time, but thanks, and if you got interested, I'll be back.
So, I guess we have half more questions.